understood the concept of shift of origin, we are going to apply this concept to solve some questions. Now look at the very first question based on the concept. Over here, you can see that there is some composite shape given to us and you are given the x and the y axis. Now look at the position of the entire composite shape with respect to the x and the y axis. You will find that some part is present in the first quadrant, some has gone to the second quadrant, some very small part has gone to the third quadrant, and then there is some part in the fourth quadrant. Now, if you try to find the coordinates of the standard shapes with respect to the given coordinate system, it will become very difficult to find the coordinates of the centroid. Students, look at this. If you try to take this particular shape over here, first of all, it is not a standard shape. You need to transform it into a standard shape. Then you will need to find the coordinates of the centroid with respect to the fourth quadrant. Likewise here also, again, this is not a standard shape. If you draw the x and the y axis, if you complete the x and the y axis, you won't be getting the standard shapes over here. So in this particular question, what I'm going to do is I'm going to shift the origin. I'm going to take some what you can say convenient coordinate system. Now the best position of the entire shape is always in the first quadrant. Now why always in the first quadrant? Because if you move the entire solid or the shape or the composite shape in the first quadrant, what will happen to the coordinates of the centroid of all the standard shapes? The coordinates will always come positive, because any point which is lying in the first quadrant will have both x and y coordinates positive. So your primary target must be always to shift the origin at such a place that the entire solid or the composite shape lies in the first quadrant. So you can very easily understand, if I want this entire shape to lie in the first quadrant, I should take the x-axis along this line of length 7 centimeter, isn't it? So here I can take the x-axis and accordingly I'll take the y-axis passing through this particular corner, isn't it? So then I will say that the entire solid that is given to me, the entire plane lamina that is given to me lies in the first quadrant. So students, I'm going to choose the x and the y axis very wisely over here. I'm going to keep the entire composite shape in the first quadrant. So observe carefully. I'm going to take the x axis here. So let's take the x axis. So this is the x axis, isn't it? So I'm going to take this as the x axis. So this is going to be the new x-axis. So I'm going to denote it with a capital letter. So that's capital X. And likewise, I'll be taking the new y-axis here. So this is the y-axis, the new y-axis, isn't it? So I'm going to denote it with a capital letter Y. So that's y for us, isn't it? This is small o, the origin. So I'm going to take this point as capital O, the new origin. And then students, this is going to be the x-axis. So let's take this as the x-axis, the new x-axis denoted by capital X. So that's capital O, that's capital A, you can say. This is B, this is C. Take some random point D, this is point E, and that's F. Getting or not? So I have named the corners of this particular plane lamina for convenience. Now observe carefully. I want to find the centroid of, say, this shaded region. This is the shaded region that I've taken over here. This is the plane lamina that was given to me. Now if you observe, if I want to find the centroid of this shaded region, observe carefully what I'm going to do. I'm going to construct some lines over here for simplicity purpose. Observe. I can extend small OE and small OC. So any one of the lines I'm going to consider here, not both of them. We'll consider only one of the lines. Observe carefully. Okay, now observe this thing very properly. If you take this bigger rectangle, look at this. I'm going to call, say, this point as, say, M. Let's call this point as M. So O, M, E, F. Look at this bigger rectangle. O, M, E, F. So that's first rectangle. Look at this small rectangle. Small O, M, B, C. Getting or not? This is the smaller rectangle. So there's a very big rectangle over here, isn't it? The bigger rectangle, the first one, then the smaller rectangle over here, then the quarter circle. So it completes this entire shape. And from this entire shape, you remove the triangle. You will get the coordinates of the centroid for the plane lamina, the composite shape. Observe carefully one more time. I've taken the bigger rectangle here, isn't it? So this is the bigger rectangle over here, the first rectangle, then the smaller rectangle over here, and the quarter circle. And from this entire standard shapes, I'm going to remove the standard shape of right angle triangle. I will get the remaining portion, isn't it? So bigger rectangle, this rectangle, and the quarter circle forms this entire plane lamina. From the entire plane lamina, now you remove the triangle. You'll get the remaining shaded portion. This is one way of getting the answer. The second method could be, now you can take this bigger rectangle, this horizontal rectangle over here, this rectangle, then again this smaller rectangle you can take, getting or not, and then the quarter circle. So both ways you will be able to cover this entire portion, and from this entire portion you remove the triangle. Isn't it a very simple concept? So I'm going to remove this particular line because this is not needed. It was only drawn to make you explain that there could be two different ways in which I could have taken the rectangles. So here my first rectangle is OMEF, isn't it? So I'm going to take the first rectangle here, the first standard shape. It is OMEF. So let's take here rectangle O, M, E and F. OMEF, isn't it? So always, students, you should remember that we should draw the diagrams with respect to the original X and the Y axis. The location of the solid should be kept in such a way that it is with respect to the original X and the Y axis. Here we are going to consider the new coordinate system, the capital X and the capital Y, because this entire plane lamina then remains in the first quadrant. So let's take the capital X and capital Y here. So this capital X and this is capital Y. So I want to make a rectangle. Now my challenge is to know the dimensions of the rectangle, isn't it? I need to know what is the dimension of the rectangle. So observe very carefully. You can very easily see that this length of EF is 12 centimeter. So the width becomes 12 centimeter. And look at the height, students. OF is the height, isn't it? The depth, you can say. OF is the depth. So you can observe that this length is given to us as 8 centimeter. The length of small OM, isn't it? Is 8 centimeter. And the radius is 10 centimeter over here for the quarter circle. So the total length here becomes 18 centimeters. So that's 12 centimeter. That's 18 centimeter. So I can draw a rectangle whose dimensions are going to be 12 by 18, or you can say 18 by 12, one and the same things. So here the horizontal distance OM or EF is 12 centimeters. So this length given to us is 12 centimeters, isn't it? Further, what about the vertical height or the depth? You can say this EM, or you can say OF. It is going to be 10 plus 8. So that's 18 centimeter. So here I get this length as 18 centimeters, isn't it? Now you can very easily identify. Let's name this also. What is the name? OMEF. So that's OM, E and F. So you can observe that a rectangle is definitely a symmetric shape. So it will have the two lines of symmetry, isn't it? So these are the lines of symmetry, and you can very well observe that the lines of symmetry will intersect at the centroid. So I'm going to call it as G1. So here the horizontal distance of the centroid is going to be the X coordinate, and the vertical distance of the centroid is going to be the Y coordinate. But observe carefully, this is now going to be X1 bar and Y1 bar. Have you noticed I have made use of capital letters, capital X and capital Y. So this is X1 bar and Y1 bar. So students, you need to understand here that the coordinates that you have taken should be capital X and capital Y, because we have shifted the origin. So X1 bar and Y1 bar, they denote the X and the Y coordinate of the origin. So now let's write the values of X1 bar and Y1 bar. From the diagram, you can easily identify that X1 bar is going to be, if I'm going to call this as B, so this becomes B upon 2. And if I call 18 as D, so this distance is going to be D upon 2. So the very first thing, I should always write the area. So let's write area. So I'm going to write A1. It is going to be B into D. So that's 12 into 18, isn't it? 12 into 18. If you want, you can multiply this. So that's 12 into 8. So 12 into 8, that's 96, isn't it? So 12 into 8 is 96. You write 6 and then carry 9. 12 ones are 12 and carry 9 becomes 21. So that's 216. If you can observe, the units are given centimeters. So this is 216 centimeter square. Let's write x1 bar. Make sure that you're going to make use of the capital letters now, students. Capital X1 bar. So x1 bar is going to be B upon 2 and B is 12. So B upon 2. So that's 12 upon 2, or you can say 6 centimeters, and then you take y1 bar. So y1 bar is going to be D upon 2. So D upon 2 is 18 upon 2, isn't it? So 18 upon 2, which is 9 centimeters. So I've got x1 bar and y1 bar. Now I did not worry about the signs of the x and the y coordinates because I have kept the entire plane lamina in the first quadrant, and we know that in the first quadrant the x and the y coordinates are always going to remain positive. So that was all about the very first standard shape, the first bigger rectangle OMEF, isn't it? Now let's take the second standard shape, which is the smaller rectangle. So there was this bigger rectangle, so I'm going to call it as A1, then the smaller rectangle, that is going to be A2, and the quarter circle, I'm going to call it as A3. So let's take the smaller rectangle. Now students, you should always take the position of the plane laminas or the standard shapes with respect to the original x and the y axis. Here I have kept the entire plane lamina in the first quadrant with the new x and the new y axis. So wherever the position I'm going to tell for the standard shape, it should be with respect to the capital X and the capital Y axis. So I'm going to take the second rectangle now, students, here. So who is the second rectangle? Can you name it? The second rectangle is small o, isn't it? Small o M B C. So that's small o M B C. Getting or not? Now let's get the diagram for this particular rectangle also. So there is this y-axis, there is this x-axis. One of the sides of the rectangle are along the x-axis, and then you can observe that this distance is 12 centimeters, isn't it? So the rectangle is kept at a distance of 12 centimeters from the capital y-axis. So I'm going to draw the diagram accordingly. So let's take, this is the y-axis, the capital Y, and we can draw the capital X-axis here and take a rectangle over here. This is our rectangle, isn't it? Now, what is the name of this rectangle? Let's name the rectangle also. It is small o here. Then there is MBC, isn't it? Small o M B and C, and this point is capital O, the new origin. What is the length of OM? Length of OM, if you remember, it is how much? It is 12 centimeter. Now remember, this diagram is not according to scale. This is only a representative purpose diagram, isn't it? We just need to understand where the solid, where the plane lamina, where the standard shape is kept with respect to the X and the Y axis. Now, can you get me the dimensions of this particular rectangle? Observe carefully. If you want to see the dimensions, it is very simple. Do not look at the 7 centimeter. It's no use. Observe here. This is 10 centimeter, the radius of the quarter circle, which is nothing but the side of the rectangle. So that's 10 centimeter, and this length is 8 centimeter. So you can tell the dimensions here. This horizontal length is 10 centimeters, and students, the vertical length is 8 centimeters. So this distance is given to us as 8 centimeters. Now, again, it's a rectangle, isn't it? If it is a rectangle, again, you will have the lines of symmetry. So let's draw the lines of symmetry. So this is the line of symmetry. This is also the line of symmetry. So let's name them. These two are the lines of symmetry, and I know that the centroid is definitely going to lie on the line of symmetry. So I can say I can have the line of symmetry's intersection. This is G2, isn't it? Now you got to observe very carefully. You want to tell the coordinates with respect to the original y and the original x axis. So that's the centroid G2. So you observe here, I'm going to draw the horizontal distance. This is the horizontal distance. This is the distance of the centroid G2 from the y-axis. So this is going to be x2 bar. Have you noticed I am using the capital letters? So that's x2 bar. Likewise, students, I'm going to take this vertical distance, the perpendicular distance, isn't it? So these are the perpendicular distances. So this is going to be y2 bar. So now you can observe there is x2 bar, there is y2 bar. So can you tell me what could be x2 bar? Is it going to be 12 centimeter, this length 12 centimeter plus this smaller length which is going to be 10 upon 2? Listen, this is 10 upon 2. Whereas this y2 bar is straight away going to become 8 upon 4, isn't it? Very simple it is. So let's very quickly write the areas and other things. So you can now tell me what is the area of this particular rectangle. So it's very simple. It is B into D. So that's 10 into 8. 10 into 8, or you can say 80 centimeters square. That's for the rectangle. Then you can take x2 bar, students. Let's take x2 bar. So x2 bar is going to be what? 12 plus 10 upon 2. So that's 12 plus 10 upon 2. So that's 10 upon 2 is 5. 12 plus 5 is 17 centimeters. So that's x2 bar. And let's get y2 bar, students. So 8 upon 4. That's very 8 upon, sorry, it is 8 upon 2. Very sorry for that. So 8 upon 2, that is going to be 4 centimeters. So I get here y2 bar as 8 upon 2, that's 4 centimeter, isn't it? So y2 bar is going to be 8 upon 2, that is 4 centimeter. Now, once I've got A2, X2 and Y2, that was all about the second rectangle. So I have taken the very big first rectangle, the smaller second rectangle. Now let's work out with the quarter circle, isn't it? That's the third standard shape that I'm going to take. And finally, students, I'm going to take the triangle. This is the last standard shape that I am going to consider, because this standard shape I want to remove from the plane lamina, isn't it? This standard shape needs to be removed, so its area is going to come negative. So that's the reason I'm going to consider the triangle at the end. At this moment, I'm going to consider the quarter circle first. So let's consider the quarter circle. Now, you need to identify where this quarter circle is placed. This is very important stuff. I need to find the position of the center of this quarter circle. Now, students, it is very simple to understand. Observe carefully. If I draw the horizontal distance over here, this horizontal distance, if you see, is nothing but 12 centimeter. So this is 12 centimeter, the horizontal distance, isn't it? And look at the vertical distance, it is 8 centimeter. That means your quarter circle is placed at a distance of 12 and 8 centimeter from the y-axis and the x-axis. This is a very important information you should always be having. Look at this. Look at the position of the quarter circle. You should have the positions with respect to the original x and the y-axis. So look at the center, where the center is placed for the quarter circle. That is the important point you should be noting down. The center is placed at a distance of 12 centimeter. From here I can observe this 12 centimeter, and this distance is 8 centimeter. So this 12 and 8 centimeter for the origin O. Getting or not? So here this is with respect to the new coordinate system. Getting? Old coordinate system, the coordinates are 0, 0 itself. So I'm going to place the quarter circle at a distance of how much? 12 the horizontal distance and 8 the vertical distance. So now let's draw the third diagram, which is a quarter circle. So let's take the x and the y axis. So this is capital X, capital Y, isn't it? So there is 12 centimeter, this is 8 centimeter. This is the center. This is 12 centimeters. And this distance is 8 centimeters. You've got to be very, very, very careful about the distances. Further, students, what is the radius of the quarter circle that you know? It is 10 centimeters. You draw a quarter circle whose radius is going to be 10 centimeters. Now remember that the diagram that I'm making is only for representative purpose. It does not have the exact length. So this is your quarter circle, isn't it? What is the radius of this quarter circle? The radius is 10 centimeter. So let's write here R is equal to 10 centimeter. Now, don't we recall where the centroid lies for a quarter circle? The centroid lies at 4r upon 3 pi distance from the radii of the quarter circle. So you identify who are the radii. You can see that this is the radius, isn't it? This is the radius and it is how much? It is 10 centimeter. This is another radius. So you can say that the centroid is going to lie at a distance of 4r upon 3 pi from the radii, isn't it? So this distance, this horizontal distance of the centroid from one of its radius is going to be 4r upon 3 pi. This horizontal distance is going to be 4r upon 3 pi. This vertical distance from the other radius is also going to be 4r upon 3 pi. So can you see that these distances that I've made, the 4r upon 3 pi, 4r upon 3 pi, these are the standard values of the quarter circle, the formula, isn't it? But are these x bar and y bar? You got to ask this question to yourself. Is it x bar? Is it y bar? The answer is no. You need to always get the distance of the centroid from the y and the x axis. The distance from the y becomes the x coordinate and the distance from the x becomes the y coordinate. So are these the distances from the x and the y axis? The answer is no. That means you need to take these distances. You need to first draw these distances. So students, I'm going to extend this. Let's extend it. Okay, so this is where the extension is, isn't it? So this is 12 centimeter and then 4r upon 3 pi you have. So this entire distance is going to be x bar. Can you understand that? This is going to be x bar. So this is the third diagram. This is the third diagram, so it becomes x3 bar. Likewise, I'm going to extend the other length also here. Look at this, this is the other length. So you can say that this length is going to be y3 bar. So look at the coordinates x3 bar and y3 bar. You should always get the coordinates, the distance of the centroid from the original y and the x-axis. They form the coordinates of the centroid. 4r upon 3 pi, 4r upon 3 pi. This is from the formula of the centroid of a quarter circle, but they are not x bar and y bar in this case. So very first, let's write the area, students. I'm going to write the area first of all. So I know that the area is given by A3 is equal to pi r square upon 4 because this is a quarter circle, isn't it? So what's the radius here? Radius is 10. So I write pi into 10 square upon 4. I know 10 square is going to be 100. 100 gets divided by 4. That's 25. So my answer is 25 pi centimeter square. That's A3, isn't it? Let's quickly get x3 bar and y3 bar. Again, I did not worry about the signs of the coordinates because I have kept my entire diagram in the first quadrant. So I'm going to get here x3 bar. So let's get x3 bar. x3 bar is going to be that 12 centimeter, isn't it? This 12 centimeter plus 4r upon 3 pi where r, the radius is 10. So this is going to be 12 plus 4r upon 3 pi. So that becomes 12 plus radius is how much? It is 10. So that's 4 into 10, isn't it? So I'm going to write here radius is 10 centimeters. So that's 4 into 10. That becomes 40. You get 40 upon 3 pi. So 12 plus 40 upon 3 bar. I'm definitely going to get this answer. Let's get the answer in a short while from now. So that's x3 bar. So now let's get y3 bar. What is y3 bar going to be, students? So y3 bar is going to be 8 centimeters plus 4r upon 3 pi, isn't it? You can observe carefully. This distance is 8 centimeter and then additional 4r upon 3 pi when gets added, that becomes the value of y3 bar. So y3 bar is going to be 8 plus 4r upon 3 pi. Again, the radius is 10, so that's again 40 upon 3 pi. So I'm going to get these values 8 plus 40 upon 3 pi. So students, I have to get these calculations now. You can understand I've got x3 bar and y3 bar. So let's make use of a calculator to find the values. So we need to find 12 plus 40 upon 3 pi. So I write 12 plus, let's do 40 upon 3 pi. So students, my answer is coming 16.244138182. So you can write the answer for x3 bar as 16.24413 centimeters, isn't it? And then I need to get y3 bar, which is definitely 4 less, so it's going to come 12, but still let's cross check it. So 8 plus, again I want to do 40 upon 3 pi. So this time answer comes 12.24413. So it is just 4 less, isn't it? You can observe very carefully. That's 12.24413 centimeters. Now students, we have got the values of x3 bar and y3 bar. Now what I want to do further is I want to find the coordinates of the centroid for the fourth standard shape. Who is the fourth standard shape here? It is nothing but the right angle triangle OAF, isn't it? So that is going to be A4, isn't it? So it is the right angled triangle OAF. Now you need to know the dimensions of this right angle triangle. So if you look at the perpendicular height, let us say this OF represents a perpendicular height. So this is very easy to tell. It is going to be this 10 centimeters plus the 8 centimeters. It becomes 18 centimeters. So the height, the perpendicular height is 18 centimeters. Now what about the base, the length of OA? So you got to observe what is the length of OA going to be. Now if you again observe the diagram, the total length is 12 centimeter, this 12 centimeter plus the 10 centimeter radius, isn't it? So 12 plus 10 is going to be 22 centimeters. So from the 22 you can cancel this 7 centimeters. So the remaining distance is going to be 15 centimeters. So the length of OA is how much? It is 15 centimeters. So let's draw the last standard shape, and this standard shape needs to be removed from all the areas, isn't it? So its area is going to be negative, but let's not write it over here. We will keep the area positive here. When we write the formula, there we will take the negative sign for the fourth standard shape. So first of all, I need to draw the diagram. Let's draw the diagram. We need to have a right angle triangle whose perpendicular sides, the perpendicular sides are directly lying along the x and the y axis. So it is very easy to identify, isn't it? So here I'm going to draw this x and the y axis. So let's make use of capital letters. Be very careful because we are taking the coordinates with respect to the new coordinate system, isn't it? So capital X and capital Y are the x and the y axis. Then you need to draw a right angle triangle. So let's draw a right angle triangle such that its height is 8 centimeter plus this is how much? This was 10 centimeter. So this is 18 centimeter, and then there is the base which is 15 centimeter. So 18 and 15 centimeter. What is the name of this triangle? It is capital O, capital A and F. So O, A and F. Likewise, if you remember your quarter circle, the names is going to be small o, c, d, e, isn't it? So I can name this as small o, c, d and e. Now these names are only for identifying the standard shapes. So I have this right angle triangle. I know the distances, the perpendicular height, you can say this is going to be h. So h is going to be, the perpendicular height is going to be 8 plus 10. So it was 18 centimeter, and the base, this is the base B. So the base B is going to be 15 centimeter, isn't it? So this horizontal distance was 15 centimeter. So I know for a right angle triangle, where does the centroid lie? It lies at 1/3 distances from the perpendicular sides. So these are the two perpendicular sides. So you draw two lines in such a way which are parallel to these perpendicular sides, and they are at 1/3 distances of the perpendicular sides. So I have this one parallel line and the other parallel line. So this is the centroid, say G4, and the horizontal distance is going to be x4 bar. The vertical distance is going to be y4 bar. It is directly the distances from the x and y axis, isn't it? Now, you know that this x4 bar is equal to 1/3 distance of B, because this distance was B upon 3, isn't it? Likewise, this y4 bar is going to be 1/3 distance of h, because this distance was h upon 3. So you have B upon 3 and h upon 3 as x4 bar and y4 bar. So very first thing, I will write the area. So what's A4 here? It is half into product of perpendicular sides, isn't it? Half into the product of the perpendicular sides. That's 1/2 into, what are the perpendicular sides? It's 18 and 15. So 1 upon 2, 18 into 15. So 18 and 2 gets cancelled. You get 9, isn't it? And 15 into 9 is going to become 135. So it's 135 centimeter square. That's A4, students. That's the area of the right angle triangle. Now I need to tell x4 bar. It is very simple. It was B upon 3. So let's write here x4 bar. Again, I did not worry about the signs of the coordinates of the centroid, because the entire composite shape has been considered in the first quadrant. So all coordinates are going to remain positive. So x4 bar, students, is going to be B upon 3. So I write here B upon 3. So what's B? B, you know, it is 15 centimeters. So that's 15 upon 3. 15 upon 3, that is going to be 5 centimeter. And let's get y4 bar also. So I'm going to get y4 bar. So y4 bar is going to be h upon 3. H is 18. So I write here h upon 3. That's 18 upon 3, which becomes 6 centimeters. So students, so far what things have I got? I have got areas and x bar, y bar values for all the 4 standard shapes, isn't it? Now I'm going to get the final coordinates of the entire composite shape, capital X bar and capital Y bar. Now capital X bar and capital Y bar, the formula we remember, it is summation of AI xi upon summation of AI, and y bar is going to be summation of AI yi upon summation of AI. So both the formulas is requiring the value summation of AI. So I should be getting the value of summation of AI first. So students, let's get the value of summation of AI. Now remember, there are 3 standard shapes whose area I'm going to keep, and 1 standard shape whose area I'm going to remove. The 2 rectangles and the quarter circle are going to be positive areas, and the triangle is going to be a negative area because it has to be removed from the composite shape. So here summation of AI is going to be A1 plus A2 plus A3 and minus A4. So A1 plus A2 plus A3 minus A4. Let's do it. A1 is 216, isn't it? So A1 is 216 plus what is A2? A2 is going to be 80. So A2 is 80 plus what about A3? It is 25 pi, isn't it? So you should be very careful while writing the values. A1 was 216, A2 was 80. A3 is 25 pi, so I write here 25 pi minus, what about A4? A4 is 135, isn't it? So that's minus 135. So I'm going to get this value 216 plus 80 plus 25 pi minus 135 in a short while from now. Let's leave it at this position over here itself. Now once I get the value of summation of AI, now I am definitely in a position to get the values of x bar and y bar. So very first I'll write the formulas. Now remember, you are going to get the x bar and y bar with respect to the new x and the y axis. Later on I will need to make use of the shift of origin to get the original coordinate. So that part we'll solve a little later. So first of all, I'm going to get x bar here. So my formula for x bar, I know it is going to be summation of AI into xi bar upon summation of AI, isn't it? So you know how to get the answers. So that's 216 into x1 bar, that is 6. So I'll write the values over here, 216 into the value of x1 bar, which is 6, then plus A2 into x2 bar. So A2 is 80 into x2 is 17. So that's 80 into 17. Then plus you need to do A3 into x3 bar. So A3 is 25 pi. So I write here 25 pi. This multiplies with x3 bar, which is 16.25 2, 4, 4, 1, 3. Getting or not? So that's A3 into X3 bar. And finally, I'm going to do A4 into X4 bar. But I should be careful that I need to put a negative sign, students. Why the negative sign has come? Because this area, this standard shape is removed from the composite shape. So minus of, what's A4? That's 135. Isn't it? 135. And it multiplies with X4 bar, which is 5. And this entire thing is going to get divided by summation of AI. So I'm going to get this answer in a short while from now. Let's wait for some time. So that's the value for X bar. So I'm going to get my answer here. So let's write answer over here, X bar. Likewise, students, I'm going to get the value of Y bar also. It is going to be summation of AI into YI bar upon summation of AI, isn't it? So this time I'll do 216 into Y1 bar, which is 9 centimeter. So I write here 216 into 9, then plus the area 80, isn't it? The area is 80 over here. Area is 80. It multiplies with Y2 bar, which is 4. So 80 into 4 plus the next area is 25 pi, isn't it? The next area is 25 pi. It multiplies with Y3 bar, which is 12.24413. So I write here 12.24413, then minus of 135 into, what is Y4 bar? It is 6. It is 6 here, and this is also going to get divided by the area, summation of AI. So now we need to take the help of the calculator. So let's take the calculator and get the values of, first of all, summation of AI. So we have this 216 plus 80 plus 25 pi. You should be very careful with the calculation, students. And minus 135. So my answer is coming 239.5398. So I can write this answer as 239.54. So that's 398. So I write 54 centimeter square. That's the area. So I'm going to use this over here. 239.54, and here also 239.54, isn't it? So I've got my answer for AI. Now I need to proceed further to get the answer of X bar and Y bar. So let's do the other calculation, students. It is 216. Be very careful with the calculations. You can do the calculation simultaneously along with me. So 216 into 6 plus 80 into 17 plus 25 pi into 16.24413, isn't it? And then minus 135 into 5. So I've got some answer here. This gets divided with 239.54. The answer is coming 13.596. I can write it as 13.6. Okay, so I'm going to write my answer as 13.6 over here. This is going to be 13.596. So 13.6 centimeters. Let's cross check our answer for summation of AI. It was 216. Then plus 80 plus 25 pi, isn't it? And minus of 135. So that's coming. Yes, it is absolutely correct. It is 239.54. Now let's do this other calculation. So this is 216 into 9 plus 80 into 4 plus 25 pi multiplies with 12.24413, isn't it? And then finally minus 135 into 6, you get some answer. This gets divided by 239.54. Your answer is coming 10.08454. So I can write the answer over here as 10.0845 centimeters. Getting or not, students? So I've got my answers over here. But you got to understand that these answers that you have obtained, these are the answers of capital X bar and capital Y bar. They are not the answers of small X bar and small Y bar. Students, you have got the coordinates of the centroid with respect to the shifted origin. You have shifted the coordinate axis. This was the original x-axis. This was the original y-axis. Isn't it? It has been shifted to capital X and capital Y. So these coordinates coordinates are coordinates of the centroid. That is for true, but they are with respect to the capital X and capital Y. You need to find these coordinates with respect to this particular origin. Getting or not? So students, you tell me, this is the most important part. If you understand this, you have understood the question. You have understood the concept of shift of origin. Observe carefully. I know this is origin O. Its coordinates are 0, 0. Getting or not? So this is your x-axis. This is your y-axis. This is capital X and capital Y. This is the origin where it is shifted. Now remember, the new coordinates of the new origin is definitely 0, 0 because its origin, its coordinates has to be 0, 0. But students, this new origin also has old coordinates which are H and K. Getting or not, students, is very important. H and K are the old coordinates of the new origin. So this is the new origin. I want to tell the old coordinates. So you want to tell the distance of this origin O with respect to the original x-axis and the original y-axis. Did you notice? Observe. You wipe out the entire diagram from here. Just focus on the x-axis, the y-axis, and the new origin. You can observe that this is the x-axis, this is the y-axis. So if you complete the x and the y-axis here, you see that the origin, the shifted origin, is lying in the third quadrant, and if it lies in the third quadrant, its coordinates are going to be negative. So students, look at this horizontal distance, isn't it? This is the horizontal distance. So what is the horizontal distance of the new origin from the y-axis? Always and always remember, if I want to tell the x coordinate of a point, the x coordinate of a point is always the horizontal distance from the y-axis. So this is the y-axis. Observe carefully. This very big line is the y-axis. This is where your origin is. You want to tell this distance. So this distance I want to find, and this is nothing but 12 centimeter, isn't it? And since it is in the third quadrant, this is going to be minus 12. Very important, students. Have you understood? Have you realized why this value is minus 12? So now I've got this as minus 12. Likewise, I want to get the distance of the same origin from the x-axis. The distance from the x-axis will become the y-coordinate. So this is the x-axis here. This is the x-axis. This is the origin. So this becomes the y-coordinate. It is 8 centimeter. And students, this is which quadrant? This is the third quadrant for the new origin with respect to the old x and the old y-axis. So this is going to be minus 8. That means the coordinates, the old coordinates of the new origin h comma k is minus 12 and minus 8. So here this h is minus 12 and k is minus 8. Now students, don't you recall that capital x is equal to small x minus h, and small x was capital X plus h. You need to remember your formulas of shift of origin. They do not change for any quadrants. Remember, the formulas are not going to change for any of the quadrants. If you recall, I'm going to write it over here. Let's write over here. Small x is capital X plus h. You need to note down these formulas. Small x is capital X plus h and small y is capital Y plus k. We have already seen the concept of shift of origin, isn't it? So you need to note down those formulas from there. Small x is capital X plus h and small y is capital Y plus k. So students, let's get the coordinates of the centroid with respect to the original x and the y axis. So here x bar is going to become capital X bar plus h. So what is capital X bar that I have? It is 13.6. So I write here 13.6. And what's the value of h? The value of h is minus 12. So I write here minus 12. So that's 13.6 minus 12. And then students, I want to do the calculation for y bar also. It is going to be capital Y bar plus k. So what is y bar value? It is 10.0845. So I write here 10.0845 minus of, what's the value of k? It is minus 8. So that's minus 8 here. I want to find these values. So let's again make use of a calculator to avoid any kind of mistakes. So students, I want to do 13.6 minus 12. It is going to be 1.6 obviously, isn't it? So I'm going to write here the answer as 1.6 centimeters. That's my answer for x bar. And likewise, I want to do 10.0845 minus of 8. That gives me 2.0845. So that's 2.0845 centimeters. So these are the values of x bar and y bar. Students, this was a very big question, isn't it? This needed the concept of shift of origin, but it was required at the end. But again, you need to have the idea of the shift of origin, because then if you try to solve this question with respect to the original x and the y axis, it will become terribly difficult to get the answer. So sometimes it makes sense, it is a wise decision to shift the origin to a very convenient place so that the entire diagram falls in the first quadrant. If it falls in the first quadrant, then we can easily say that the x and the y coordinates for all the standard shapes is going to be positive, and later on students, you can simply get the coordinates of the original centroid by making use of the concept of shift of origin. So students, this was all about this particular question. We will take some more questions which are based on the concept of shift of origin.